Hello grade 10s, it's now on to exercise 13D, solving trig equations. So in exercise 13C you solved a couple of equations. We're now on to a wee bit more complex ones. Now I don't want to do all of these, but I will just do 1A, 2A, and 3A to kind of get you started. So we've got 1A, cos 2x equals root 3 over 2. Now it says no calculator again, so what do you need to know? You need to know your triangle. What triangle do I need to know? Well, what one has root 3 over 2? Let me just draw that a bit smaller. So if I put 30 there and I put 60 there, then 30 is 1, 2, root 3. So I can see I've got root 3 and I've got 2. So and it's cos. So cos is adjacent. So adjacent over hypotenuse. So it's root 3 over 2, which is 30. So if I was to say cos 2x equals root 3 over 2, then 2x is equal to, and then I do inverse cos root 3 over 2. Now, I've just used my little triangle to work out that inverse cos root 3 over 2 is 30 degrees. So I hope everyone's happy with using the little triangle or learning the exact values. It's very important because it's a non-calculator paper 1 type question. Right, now next thing I need to know is the range, which is negative 180 to 180. So if you think about the cosine graph, remember it goes down and back up, and then it's symmetrical on the other side. Now 180 is really just to this point here, that's 180 and that's 180. So that's negative 180 here and that's 180 here. So I'm looking for all the angles based on that. However, there's one little issue. There is a 2 here. And what that means is I'm going to get all the answers based on this, but then I have to divide them all by 2 at the end. So I need to work out what are all the possible answers for root 3 over 2. And now root 3 over 2, if you want that as an exact decimal, you're not allowed calculator, but you should kind of know it roughly. 0.86 or 87, so it's always going to be close to the top. So if I was to draw this in a different color, let's go for a nice yellow. That there is approximately the points. So it's actually only 2 points because it's only from negative 180 to 180. Now I'm just going through all the theories. I wouldn't spend all this time doing it, but it's just so you can visualize it. Now what's good about the cosine graph is it's symmetrical, so the answer that I get here is going to be the same as the answer here, but only this one is going to be negative and this one's going to be positive. So thinking about my cast diagram, all sine, tan, cos, the root 3 over 2 is positive and it's cos, so I'm using these two quadrants where this is 30 and then in here is going to be 360 minus 30. Or if you think about it in the negative side, it's going to be 0 minus 30. And here is just going to be x, so therefore that's just going to be 30. Now 360 minus 30 is going to be 330. But we don't need that because it's outside the range. We just need the positive one, 30, and the negative one, 30. Okay. Now, the problem here we face is we have this 2 here. So I basically want to find x equals, I don't want 2x equals. So what you do is, although I said here not to count it, we wouldn't normally count this because it's negative 180 to 180. But because this 2's here, we are going to include this. Okay? So that means I'm going to include 330. And because it's symmetrical, I've also got negative 330. And the reason I do this, as you'll see, is now, if I just change colour so you can see the final answer, is now to find x, what am I going to do with this 2? I'm going to divide everything by 2. So that now becomes 15. That now becomes negative 15. That now becomes 165. And that now becomes negative 165. And what do you notice now? You notice that, well, obviously these two are in the range, negative 180 to 180. And now, although we weren't going to count 330 and negative 330, when I half it, you can see that they now are within the range. So those are my answers to 1A. So you've got to do the same for B, D, and C. You've just got to remember some of the rules. So for part D, I see a squared in there with a sine and a cos. So you might have to use your trig identities, which I've had to use in the past. So remember that sine squared x plus cos squared x equals 1. And also that sine x over cos x equals tan x. So you got to remember your trig identities as well in order to make this easier for yourself. If you've got a sine and a cos, then you're unable to solve the equation, so you need to turn it into just one. Okay. Question 2 is very similar, but I said I was going to do 2A, so I'm going to do 2A. But the reason why it's slightly different is it's in radians, which to some of you get freaked out with this. So I'm going to rub out the trig identities. You all know that anyway. You've got that written down in your notes, and you should know it off by heart. So let's say I've got sine 2 theta is equal to negative a half. So hopefully you've spotted that this is negative now, so this is going to change things. Also, always draw a little graph. It's from negative pi to pi, which means negative 180 to 180. So if I draw the sine graph, it goes up and down and up. And then on this side, it's going to go down, up, and back down again. So where is 180? 180 is here and negative 180 is there. So I'm only looking in this part of the graph, and I'm looking at negative a half. So where is negative a half? Well, negative a half is approximately here. So that means I'm only wanting this one and this one. So I'm looking for two values. for 2 theta. But remember, I've then got to divide all my answers. So really what I'm finding, I'm going to find all of these and then divide it by 2. If it was just sine theta equals negative a half, for that range it would just be these two. But because it's got the 2 theta, I'm going to find them all and then I'm going to divide them by 2. I hope that's clear. So, know your little triangle again. So what have I got? I've got 1, I've got 2, and I've got root 3. And sine is opposite over hypotenuse. So opposite over hypotenuse. So that means 2 theta is equal to inverse sine. Now I don't do the negative, I just do it for a half. So 2 theta is equal to 30. Okay, now 30, what you need to remember in the cast diagram, 30 is x. Okay, but because this is negative here, I'm not going to be using this quadrant. The quadrants I'm using are the opposite. So if it was positive, I would use all and sine, but because it's negative, I'm going to be using tan and cos. So what do those quadrants say? They say 180 plus x, and they say 360 minus x. Okay, why am I using those quadrants? Because it was negative a half. If it was positive a half, I would use the positive quadrants, all in sine. So, what are my answers then? Well, tan is going to be 180 plus 30, which equals 210. And this is going to be 360 minus 30, which is 330. So what are these answers I've just found? Well, that is 210 here, and that is 330 there. So now I need to find out what the negative ones are. So how do I find out what the negative ones are? Well, I can see that this is 0 here, so therefore it's the negative one's just going to be negative 30, which is obvious because I wanted the negative of it. So if this is 0, for negatives I go in this direction. So I'm going to have negative 30. And then this one, here is the negative 180 line, and it's just to the right of it. So the other one's going to be negative 180 plus 30, which is going to give me negative 150. So the 4 angles which I've stated is there. So negative, I hope by drawing these lines I'm not confusing you. So those are the 4 angles I've just calculated. Next thing, sum it all up. So what have I got? I've got 2 theta. Now I know I was using x, but it's actually theta, so that was my fault for defining the variable wrong. So 2 theta is equal to negative 30, negative 150, (210) and 330. However, I've got to divide all them by 2, so negative 15, negative 75, positive 105, and then positive 165. And you can see that all of these are within the range of negative pi is less than or equal to theta, which is less than or equal to pi. So all of these match this range. However, if my range is in radians, which it is, this is in radians, then I need to give my answer in radians. So how do you write 15 in radians without a calculator? Well, you should know that pi by 4 is equal to 45. Well, to get 45 into 15, I would divide it by 3, wouldn't I? So if I divide 45 by 3, that means I need to divide pi by 4 by 3, which will then become pi by 12. So negative 15 is going to be negative pi by 12. And then 75, well, if I know 15 times 5 is 75, then that's going to be 5 pi by 12 with a negative. And then I'm going to keep going in the same direction. 105 is going to be 7 times 15, so it's 7 pi by 12. And 165 is going to be 11 times 15, which is 11 pi by 12. So yes, I like to work in angles and then change it back into radians. Some of you might be able to just compute it in radians. That's great. It's up to you. So 2a is quite a, because it's got the negative in there, it can be quite challenging because you've got to tick the other quadrants. For C and D, you've got a squared in there instead of a, so it's basically doing another operation, but you have to do the square root first and then do all your angles. So I'll not do those ones. I'll see how you get on yourself, and then I can make another video if you're unsure. So hopefully this is enough to get you started. For question 3, have I got any more room left? Yeah, got enough room. So question 3a. What have we got? We've got 2 cos squared x minus 5 cos x minus 3 equals 0. So what you should hopefully look at when you see this is a quadratic equation. So what I'm going to say here is let cos x equal, and then I'm just going to say a. So what do I end up with now? I end up with 2a squared minus 5a minus 3 equals 0. So basically what I've done there is I've defined that I don't want to do it with cos x, so I'm just going to call cos x the variable a, and then instead of having cos x, I've just replaced it with a. So hopefully that makes sense to you. Now I've got a very simple quadratic, which I told you at the very beginning of the year how important it is to know how to factorise. So I've got 2a squared minus 5a minus 3. So how do you factorise? I want it into double brackets. So I'm going to multiply the 2 with the minus 3, which gives me minus 6. What multiplies to make minus 6, but adds to make minus 5? Well, that's the area, it's minus 6 and 1. So I'm going to get 2a squared minus 6a plus 1a minus 3 equals 0. Then I'm going to factorise the first 2, which gives me 2a bracket a minus 3. And then factorise the second 2, well, 1's the highest common factor. How do I know I'm right? Well, these 2 brackets are the same. So my 2 brackets are 2a plus 1 and a minus 3 equals 0. So what does that leave me with? That leaves me with 2a plus 1 equals 0 and a minus 3 equals 0. So therefore a is equal to negative a half and a is equal to 3. Okay, so we haven't even done the trig equation yet. All we've done is taken 2 cos squared x minus 5 cos x minus 3 and found out what a is equal to using this substitution. So now, not finished, I need to go back and change a back into cos. So here I've got a and a. I'm now going to rewrite that as cos x equals negative a half. And I'm going to write cos x equals 3. So what do you end up with? You end up with some trig equations. So this one here is negative a half. So and this one here's 3. Now, if you remember the cos graph only goes from 1 to negative 1. So any value that's higher than 1 or less than negative 1 cannot be calculated. So this will actually give you, if you were to do this in a calculator, which is not allowed, you cannot do it. It's an error. Because the maximum value is 1 and negative 1 for the cos graph. So you can't do inverse cos 3. So that there is out. So that leaves me with just cos x equals negative a half. Now we've got that negative in there, which means I need to tick the other quadrants, and it's a half. So if I remember my little triangle, it's 1, 2, root 3, and cos, that means 60 is here. So adjacent over hypotenuse. So that means x is equal to inverse cos of a half, which is going to be 60. Now, again, I don't do anything with that 60 just yet. I draw out my cast diagram, and because it's negative, that means I'm not going to do the all in the cos quadrant. I'm going to do the sine in the tan quadrant. So this is 180 minus x, and this is 180 plus x. Now, I can't remember, the range is from 0 to 2 pi, so that's nice and easy. From 0 to 2 pi. So it's in radians, and it basically just means from 0 to 360. So if I drew the cos graph, and I put in negative a half, I'm basically just looking for these two values in here. So 60 is not the answer. I've got to use the negative quadrants. So x is equal to 180 minus 60, and x is equal to 180 plus 60. So that equals 120, and that equals 240. So 240 is this one, and 120 is this one. And that's it, because that's in the range of 0 to 2 pi. So those are my answers. So in question 3, the trig equation part is much easier than 2 and 1. However, you've just got this quadratic part that you need to make sure that you say let cos or sine equal a, and then just factorize the quadratic, and then you can go from there. Alright people, have a good week. Just let me know if there's any other questions that you're really stuck in, and I can chat to you through private message and see if I can help you.